I come from University of Zagreb, and I present here a joint work of mine and my colleague Marina Ninčević. We did compare two exam evaluation methods for objectivity. Every one of us is a teacher, I believe, and every one of us do construct exams. And we know that the objective evaluation of exams is a very important question. The question that we'll tackle here is how objectively do we evaluate written mathematical exams? Namely, I'm a mathematician and I teach statistics and other mathematical subjects at the University of Zagreb. And here, when we speak about mathematical exam, I do not mean the mathematical exam with objective tasks, which have either right or wrong answer, but I refer to problem tasks, which have a right answer and a wrong answer and many in between. So there are many opinions on objectivity from the ones that say that it doesn't exist, and the others that say that it is hard to achieve and that we will always have somehow subjective exam evaluation. There are very little research on this subject, although we all meet the problem of objective evaluation. There are a few research given here. The one is white, which distinguishes between objective and subjective exam tasks. So we speak about how to evaluate subjective exam tasks. In research performed in 2011, the same exam was verified by 6 teachers and some disagreement was found. One way to tackle with this problem is suggested in a work from 2015, which suggests creating detailed scoring criteria in order to ensure objective evaluation. So we will address the question, and how can objectivity be increased in evaluation of written mathematical exams that contain problem tasks? More precisely, can different evaluation methods increase the level of objectivity in exam evaluation? The object of this research was an exam in a university statistics course that contained of 5 problem tasks with a maximum of 8 points assigned to each of them to the correct solution. And the subject is a total of 35 students on a course that were present on the course that year. So we had their exams, and we wanted to compare the next 2 evaluation methods for objectivity. The one we call a serial evaluation method, and it assumes evaluation of exams student by student. I'll explain that later, while the parallel evaluation method assumes evaluation of exams task by task. So we did choose the names for those evaluations, mimicking electrical circuits and joints in them, for example, joining resistors. A serial evaluation method assumes that a teacher takes a student exam and goes through one individual student exam from the first to the last task. Our exam had 5 tasks, so the serial method would assume teacher to evaluate tasks from 1 to 5 to first student, and take the other and evaluate the whole exam. So this is the serial evaluation method, and also evaluation student by student. It resembles a serial connection of resistors, for example, from electrical circuits. And the parallel evaluation method assumes evaluation of exams task by task. So a teacher takes all the exams and evaluates just one Sorry?
Sorry to interrupt. Are you going on with the slides because we don't see that you are changing? So you
yes,
can,
I am. I am.
So
Sorry.
Close slideshow, and just click on the slide on your left side so we can. No. Okay, share again.
I don't know what can I do.
Slideshow. Share again as you had it before, because you don't have another option, as I see.
Okay, I've tried to do that again. Start the screen.
Yes, screen. Share screen. Okay, now we see the slides. That's great. That was I was testing before.
Thank you, and sorry for this. I saw this happen to another lecturers, but I wasn't aware.
Okay, go ahead where you are. So that's okay.
Okay. So let me just show you. There is one example of one student's work, and here is this diagram. You can see it now. Okay.
Yes, now it's fine. Perfect.
Okay. So I was describing evaluation methods, the serial, which assumes evaluation student by student, and the parallel, which assumes evaluation task by task. So it resembles also the parallel connection of resistors in electric circuits. Just to illustrate one problem task that was in this exam, so it was asked, what is the probability of obtaining a reducible fraction if one dice throws a dice 2 times, and the first number is declared the numerator of the fraction and the second denominator? What is the probability that this fraction is reducible? So exact solution is that there are 13 such pairs, and so the probability is 13 out of 36, which gives a maximum of 8 points. For a solution that misses some of those fractions, we decided that each extra or missing reducible fraction will result in -1 point. Maximal reduction is -4 points. And if students mentions the total number of fractions, then it gets 2 points. And if it writes probability as a fraction, additional 1 point. So there are pictures of some of the students' works, including the totally correct one, given here in the middle of the right-hand side. Given here on the left-hand side, one with one extra fraction, which is not reducible. You know what reducible fractions are. Those are fractions in which both numerator and denominator can be divided with the same number. So there is a list of all 13 of that such. There is one additional, and there are some lists that are incomplete. So you see, this student didn't find all 13, found only 8 of them, and this student didn't at all write neither probability. It has only the total number of fractions given here. So we used to evaluate exams by the serial methods. And so we did with this exam. Some 6 months later, we decided to perform this research. And for that reason, we did repeat the evaluation, this time by the parallel method. And when we did so the same evaluator did evaluate these exams for the second time. Of course, the same scoring criteria were used, and the third party made previous results invisible so that they are not available. Okay, and after performing this parallel evaluation, we decided to re-evaluate the same exam with both methods So to do both methods again. So we had 4 evaluations over a period of 1.5 years. Twice by the serial evaluation method, twice by the parallel evaluation method. There was sufficient time left in between the evaluations, so to make sure that evaluator does not recall any previous evaluation. And since all the previous results were invisible, so here you can see on this picture those empty circles, which witness removal of old scoring. So we had a data set. This is just a part of the data set. For each student, we had 4 evaluations with a serial, parallel, repeated serial, and repeated parallel evaluation methods, together with the total points that the student won. And we also calculated the differences between serial and repeated serial, and parallel and repeated parallel. These are absolute parity differences. So this data set is a typical example of so-called paired data set, because if you look at the pairs of the data, then each pair refers to the same individual. So in the rows of this table are the same students. So these data refer to the same individuals. So we did pose 4 hypotheses to test on this data. The one being that there is no statistically significant difference between serial and the parallel evaluation, between serial and repeated serial, that is H2, H3, that there is no statistically significant difference between parallel and repeated parallel evaluation. And further, we wanted to check what is the correlation what can we say about absolute differences between the results obtained by the serial, repeated serial, and parallel and repeated parallel evaluation methods. Statistical tests performed were paired sample tests, because we have a paired sample data. They were performed in the R project for statistical computing at the 5% significance level. And first 3 were 2-tailed tests, and the last one was 1-tailed. And there are critical points given here, 2.03 and 1.69. In order to perform the statistical analysis of paired sample analysis, one has to test the assumption that all data come from, that they all have common distribution. For that purpose, we did plot so-called QQ plots, quantile plots, in which if the points are aligned nicely across the reference line, then it means that those pairs come from distributions with a common
Sorry
parameters.
to interrupt again, but please speed up because time is over.
Okay.
So you can go.
I have a few more, just thank you. These are the results of our statistical analysis. It says to reject H1 and H2. So there is a statistically significant difference between serial and parallel method. Between serial and repeated serial, there is no statistically significant difference between parallel and repeated parallel method. And as for the H4, we can see even in this box plot that parallel and repeated parallel method has smaller absolute difference than the serial and repeated serial analysis evaluation. So we consider on the basis of the results that those 2 methods are different, that the parallel evaluation method does not change results significantly when repeated, while the serial does change results significantly when repeated. And parallel evaluation repeated changes results less than the serial evaluation method repeated. And therefore, we can conclude that the parallel evaluation method indeed ensures higher consistency of results. And if we consider this as a sign of objectivity, then one can say that objectivity of exam evaluation can indeed be increased by the use of the parallel evaluation method. And there is a literature used in this presentation. And I thank you very much for your attention and apologize for all those technical difficulties I had in the beginning. Thank you.